Hello, I'm Eric Snodgrass, and thank you for watching today's in-depth ag forecast brought to you by Nutrien Ag Solutions. Before we dig into the new long-range forecast data that was released over the weekend from the European model, again, that'll take us out 7 months. We're going to take a look at that in a second. I want to do a quick recap of this weekend's severe weather. All in all, we had about 300 reports of severe storms, including numerous tornado reports, and most of those were centered in the center and western part of the Corn Belt, really hitting Iowa, this section of south-central Iowa, very hard. We then saw a lot of severe winds that moved across as the whole squall line made its way through Illinois, Indiana, and parts of Ohio. And as this went racing through, some of these tornadoes were devastating in their size and strength, and also with lives lost out of this. This was a rough weekend to forecast the weather. I want to bring your attention to this. If you go to weather.gov, click on the state of Iowa, you can then get a recap of the March 5th event. This is from the National Weather Service. And the particular tornado I wanted to bring into your attention, just looking at the counties, the Madison, Warren, Polk, Jasper County tornado, this one right in through here, south of Des Moines. They have come back with an estimate that it was an EF4 with peak winds at 170 miles an hour. But on the ground, look at this, for 69.5 miles. So this is where I want you to go to get information about this tornado if you have a moment to do that. Now, just thinking about this, after this event went through, we saw a pretty massive change in the pattern, and following this, we even had quite a bit of snow. You can see here that just looking back over the last 3 days, that same area right in through here saw the backside of that system deliver in places, some places more than 6 inches, like right here on the Missouri and Iowa border. So this made the survey difficult. This also makes the cleanup very difficult, and there's a lot of people that were affected by this severe weather. Now, when I was watching this unfold on Saturday, I'd like to show you some satellite data. In this animation, what we're going to see here as I get this playing again is sun up to sundown on Saturday of that big winter storm. Now, right here at the end of the animation as the sun comes setting in, you can see the deep convection. And one of the things I want you to take note of here, because we're about to move into severe weather season, is kind of the sequence of events that got us there. A lot of low-level clouds. See that in the morning? And then what happened is that this clear sector opened, destabilized the lower levels of the atmosphere by letting some heat in. We had tons of shear in place, and these supercells just broke out right into this area. And that's the initiation point for those massive storms. But as I was watching this particular animation, there was something else that I saw that I really want to show you. And it's on this satellite animation. Now I've zoomed in here a little bit farther to the west of the severe weather into Nebraska and Kansas. As we play this one forward, I want you to notice what happened right here. Now this time of year there are a lot of prescribed burns that happen in Kansas. But look at the smoke from that particular wildfire getting ripped here all the way over into this side of Kansas. It just shows you how strong the winds were on the backside of this. Even further south into Texas, there was quite a bit of dust that was being blown around by this particular system. And so I want to see what this may mean in the bigger picture of things. And the first thing I'm going to tell you is this. As we just watch this animation one more time here, I do want to tell you that the risk of an above average severe weather season this year is higher than normal given where we are right now coming out of a La Niña. And the second thing to sing here, so far, our year-to-date precipitation ranks by climate district are exposing some areas that are really struggling in a big way for moisture. Now, you can see that there's a part of the western Corn Belt that since January 1st has missed out on a lot of precip. Now, what just came through here was great. We need more of that. But getting back into Nebraska, coming up here into the kind of the western side of the northern plains, and then stretching down into Kansas, Oklahoma, down into Texas, and this region right in through here, which has been up to this point dry. There's going to be a lot of change here, but very dry. And of course, we're looking over to the west. When you come to southern Oregon, parts of California, Nevada, the lack of any sense of southwestern jet stream flow has been very apparent since the beginning of this new year. And right now, all of these climate reporting districts with the number 130 are still having their driest start to any year since 1893 when the data collection began. And you can see this better if we just look at two other pictures. The first one's going to be our 16-inch soil moisture. Now, expect to see a lot of improvement here. I should have included more of Florida in this as well. You'll see why in just a few moments. But some of the longer-term models which we're about to examine just expanded this region of drought going forward. I'll explain the caveats to that in a few moments. But tucked in between, the really wet weather here is where I just put this X. What's going to happen in this part of the western and central Corn Belt? That's a key area. Now, the other major region we must be discussing is what happens south of this part of the Willamette Valley into California, because we're now 7 days into March, and we're running out of time. I mean, it's March and April. Those are the months that can still deliver the moisture. And we know we have a La Niña. We understand what that means. That means a highly variable Pacific jet. It means it moves a lot in the Gulf of Alaska and doesn't often give us those Pineapple Express scenarios that we need to have. And I think what that means is the likelihood of a miracle March or an amazing April is diminishing quickly. But let me explain in a few moments what it would take to get that to happen. All right. First, I would like to show you the latest drought monitor. Now, this was released last Thursday, but you've got here again about 72% of the contiguous United States showing some stage of drought, from D0, that would be just abnormally dry, all the way to D4, which is exceptionally dry. Now, I keep honing in on a few areas. That would be this part of the Southern Plains, the expansion we had been seeing into Nebraska and Kansas, getting into Iowa, although we just brought moisture into this area. And then here in the high and northern plains of parts of the Dakotas and Montana. We're going to start to see this area going back over to having class degradation. I'm starting to get very concerned about that moving forward. If we just think about snowpack, this is what we've got. Let's blow that up so you can see a bit better. This is what we got in terms of snow water equivalent. Now, this region in through here, the snowpack is pretty good. So in the central northern Rockies, in the northern Cascades, we're doing fine. What we got back in December is still, and we added a little bit over the weekend, is still helping the Sierra Nevada. But we've flatlined on precipitation, and a lot more is needed. Tucked in between is Oregon, and there's major concern about Oregon going forward. I'm also concerned, as I stated last week, about the headwaters of the Missouri River. You have brought in some snow here, but there's not much liquid in that snow when it starts to melt. Now, that's good for spring flooding, but not good for the moisture return that we're going to need to this area. Now, what I want to do is I want to take this background state I've given you and start to wrap it into the long-range forecast first. And a lot of that's going to begin with this. This looks very similar to something I showed you back in December. We're looking from today, March 7th, all the way through March 21st. That would be the equinox, by the way. And you see this? This whole area here represents strong trade winds. That's very characteristic of a developing or a strengthening La Niña. And they're meeting either slower trade winds or trade winds that have stopped or even at times come back out of the west. Now, what I'm trying to build a case for you here is that I'm getting a very strong signal by looking for convergence in the atmosphere, which is happening here, right on top of phase 5 of the MJO. And why I'm looking at this is because I want to know if we're going to get this jet, which if you're oriented here, this would be, Asia. The open Pacific and the U.S. is over here. I want to get this jet really screaming and pushing farther into the east. Right now, it is locally centered right here, extending off of Japan, but no longer making the big push all the way across the ocean. What affects the momentum transfer out of the tropics into the westerlies is where the MJO is. And there's some clues that it's coming in and going to set up somewhere here, which is about phase 5. Now, the forecast of this using these phase diagrams I feel is a bit misleading because the MJO is right now back in null space and it's forecast to come back out into phase 2, 3, and then maybe weekly over to 5. And the ECMWF doesn't even do that. It keeps it all tucked away in here. I could make an argument that we're going to get here sooner, but last month I made that same argument and the MJO collapsed again. So that's risk. But what I want to talk with you about is this. Let's just do a more broad brush approach to this. And if we're going to continue to make the case that the MJO is the most dominant teleconnection in addition to La Niña, I want to know, is it going to be spending time in phase 3, 4, 5, or is it going to be spending more time over here in phases 7, 8, and 1? Now here's the reason why. If we do get the MJO over into phase 3, 4, and 5, that promotes, I'll write it here, a southeastern ridge. If it comes over to phase 7, 8, and 1, that promotes a southwestern ridge in the United States. Let me show you. If the MJO stays in phase 3, you see the ridging that happens here? That means this whole area is going to have, well, especially this area is going to have a very active storm pattern. This means better moisture return to the Pacific Northwest, but no strong subtropical jet here. Okay, so that doesn't help California. That's phase 3. Let's go up a phase. Phase 4. Look at this, really pushing the moisture and the precip and the cold air into the Pacific Northwest, but then it's got to make this run over this ridge that extends from the southeast to New England. So all this makes the turn and really cranks up in this area. From there, look at this, phase 4. That's again a southeastern ridge. See how these are very similar? My point is, if we can get the MJO to stay over in this area, there's going to be a couple of things that are going to happen. One, I believe that this will likely increase the prevalence of severe weather in the Mid-South, parts of the Eastern Corn Belt, lower Mississippi River Valley. Okay, if that happens, it will be mild down here. If this ridge, however, backs up, it's going to be dry in the southern plains, and it's going to be drier in the Southwest in California. So we need to watch if the ridge is going to be here or if it's going to be here in this part of the jet stream pattern. Now I'm going to show you what the models are doing. It's a bit baffling, but if I just take you out there to the beginning of April, all right, that's pretty far out, but let's just get an example. The models are trying to dip this in here, do it again like that. Now that's a pretty subtle slope, but the primary ridge axis is here. This is good for the Northwest, but this produces a lot of convergent flow where I'm putting this C and all the action's just off the coast. Now why we show that is I'm going to go down to the United States view, flip this over to Precip, and show you that this is the new forecast from March 15 to April 15. And the models continue to keep this area very active, the Pacific Northwest active, but they've gone over in a big way to drier conditions here because the ECMWF is reluctant to bring the MJO out firmly into phases 3, 4, and 5. It wants to collapse the MJO and leave it collapsed or even bring it out back into the Western Pacific. That's when the ridge is here and it's much drier. I think that's the most dominant teleconnection. That's why I'm giving that to you. Now, when I look at this overall, I think we're biased way too dry everywhere east of that line. I think it's biased way too dry here. I think we're going to get more systems pulling moisture into this area. And I've got some reasons for that, but mostly they center on the MJO moving around and what I'm currently seeing from this La Niña, which has kicked up. It's gotten back into some strength as of late, and we better talk about that. So let's do that. Current picture here of ocean temperatures. We've got our signal of what we call the negative phase of the PDO. We've got to watch the cooler water here potentially for a stronger signal coming from what we call our Pacific meridional mode. But our La Niña, to be honest, I didn't think it would still look like this early March. I thought we would have peeled back a lot of this and started to see warmer temperatures there. But those strong trade winds as of late have really, just kept it going and giving it a bit of a resurgence. Okay, where's it going? The newest data from the Long Range European had a peak here in December, and it appears that we may be going back down to a weekly, or not a weekly, but a temporary re-strengthening of this La Niña here in March. But all the model members still bring it up by, let's call it mid to late spring, to neutral conditions, and then leave it there. It's quite rare to have a third La Niña in 3 consecutive winters, but the spread in the newest run is considerable. And that means that the probability of developing a full-blown El Nino by this fall, we still don't yet have a good grasp on that. And one of the big reasons is historically, predictability before what we call the spring barrier is terrible. What's the spring barrier? We've got to get past the winter position of the jet stream. We've got to get past a peak of a La Niña. We've got to get where the jet stream pattern begins to take on its spring characteristics to even have a clue as to where it's going to go going forward. So I want to preface what I'm about to share with you by saying right now might be the least predictable time of year to tell you what summer's going to be. But we have new data and we need to share it. But what I'm going to share with you here is simply model output. Let's talk about it. Brand new updates. Let's talk ocean temperatures first. I'm going to slide this forward. Let's blow it up just a little bit. There we go. I'm going to slide this forward 1 month at a time. We're going to go from March into April, May, June, and July. Let's just stop there. Some big differences are happening here. First of all, the previous run for July had much more of an El Nino signal here and colder water in the Gulf of Alaska. Now watch. The newest run has backed off on the cold water here. has weakened the return of some sense of El Nino and kept the colder water around. Do take note, right in through this area, the models are keeping things warm as well. Some of the big drought years in the Midwest had a lot of cold water here, and of course, very cold water there. That was Midwest drought we're talking about. So these newest runs, now showing more mild conditions and not a massive and quick return to El Nino, they're going to change the precipitation patterns. I will show you that in a few moments. What about the hurricane season? Well, if this El Nino doesn't come back and increase the wind shear here, and we have very warm ocean temperatures, a part of the Atlantic meridional mode and other things, this means that we could go into another season with above average risk on hurricanes. I don't think it'll be like 2021. I don't think it'll be like 2020, but I think we're going to still be above average. Let's go from there right on into, let's go into the United States view. And let me peel this back a little bit, and let's talk about our seasonal precipitation outlooks. So right now, the models are exhibiting very strong behavior toward persistence. They don't have a reason to break away from persistence. And let me explain what I mean. Persistence would be to leave the drought here. Persistence would be to leave the drought there. Keep this area wet and active in the Pacific Northwest. That's what's going on right now. There's low soil moisture here. There's ongoing drought in the west. And there's cold water in the Gulf of Alaska and also cold water in the equator. That's what persistence is. That's what got us there. But the models, as we go out now to April, May, June, July, August, May, June, July, and now June, July, August, are doing something here that I'm finding quite interesting. They're splitting everything on the Mississippi River. So they're expanding the drought into the western Corn Belt. And you're getting a sense of how this is going to happen. Possibly an early buildup of heat in the southwest. We're talking about those June days where we're hitting 110. That's going to bring in a deep heat low later in the season and crank up the southwestern monsoon. That'll then push the ridge and open it at times into the central plains. The flow then comes down like this with northwest flow and brings lots of storms into this corridor. And then we're expecting activity with hurricanes kind of pushing here along the coast. But what this means is the model at this point is not allowing for the return of good moisture into the central plains. And I'm just going to remind you, these do not exhibit skill. That's why we're trying to explain the differences. Now, what we need to watch is if the waters along the west coast warm up more significantly, this drought risk begins to shift west with it. And then we increase the drought risk for the Pacific Northwest. I think the Canadian Prairie, despite the dry signals, are going to see a lot of northwest flow and a lot of kind of thunderstorm activity. But I think it's going to extend into this part of the country as well. So that's the latest update from the model. We're trying to piece it together, but I bet you wouldn't be surprised if I showed you that the summer temperature pattern right now looks like this, where they've got the ridge, they've got the heat as well. So that's where they're expecting the best chances of being above average in temperatures. It's a good thing that the models don't exhibit high skill and that we're not past the spring barrier, and there's a lot that can still change. And the biggest thing you need to watch, actually there's two things: how quickly the ocean temperatures moderate, because that's our only subseasonal predictor. That's really it. The second thing, which is also a good predictor subseasonal but not as good as ocean temperatures, is soil moisture. If something comes through this area and eliminates, let's just go back to it, and eats this away, and that can happen, this whole forecast for the rest of spring and summer is out the door. It's all going to change. So you got to watch this with me carefully from now through, I just say the next 75 days are the most critical for us predicting summer. So let's watch it together, okay? All right, now we got to get back to some near-term weather. We have a pretty active go of it in the east right now. This is a big severe thunderstorm watch area and high wind advisory across a big section. Flooding was left in the wake of that system that went through the weekend. Got winter weather advisories, including a winter storm watch right into this part of Nebraska. You can even see the same thing happen up here in the north. So what's going on? Well, severe thunderstorms, still watching for them over here along the East Coast tonight. This is going to be the end of our severe weather threat from this system. And let's just go take a look here at the high-res NAM to get us up to speed on where this is going to be. So I'm recording this about 4 o'clock in the afternoon. So this evening, the system spreads into New England, and that frontal boundary pushes here over the Appalachian Mountains into the Mid-Atlantic, into the Carolinas. And then by the time we're to Tuesday morning, it's off. It's offshore. In the meantime, big Arctic front's pushing down here. It's going to push up some snow against the mountains of Montana. That front's going to slide through the Pacific Northwest. You can see its extent right there, bringing in some light snow. Now, after that, as we go into Wednesday, we're going to see overrunning precipitation setting up here. Once again, returning some heavy rain into an area, especially right in the mid-south that doesn't need it. We're going to get some of that snow coming right in through this area and scattered snow showers here in the northern plains getting into Manitoba and Ontario. That's through Tuesday evening, and as we play forward, that system moves into the mid-Atlantic, and our next big system starting to take shape right here. We're going to talk about that in just a second. So we got this one moving into the mid-Atlantic, spreading snow out ahead of it, and some heavier rain to the south, and that takes you out towards 6 p.m. on Wednesday night. Now after this, just take a look at the bigger picture before I get into the details. This is the whole of the next 10 days when looking at the next several systems lined up. There is a region in through here that's going to go over drier. Very wet in the southeast and New England. Without that subtropical jet, California's dry, but the flow is really going to be piling into the Pacific Northwest. And to see that, let's add it all up first with the European model. And what we're going to get here is here's the second push of moisture coming into the southeast. There's some of the snow coming on the back side, right in through here. You'll see it snow in just a few seconds. Thursday, Friday, right there. And then, as we go on out, another push of moisture. See it adding over the top of this area here, such that if I just let this go out a week from now, there's going to be a region in through here that will easily be picking up 2 inches of rainfall. Where it's backed off is right in through this area. Let's watch it by doing a multi-model analysis. Okay, GFS on the left, European on the right. Playing this forward, first system, we've already watched this in the high-res NAM, gets on out. So what we then watch after that is on Tuesday, throughout the day, we're going to see the storms coming in to the lower Mississippi River Valley. The severe weather threat here is not high. It is not high with this. It's overrunning, wrong shear setup, not enough instability, but scattered storms are a possibility. And that system moves up into the mid-Atlantic. We've seen this in the high-res models. So that one moves on out. There we go. And here we are picking up with things on Thursday morning. So now we see in both models snow spreading into this part of Kansas, Nebraska. It's in both models. That's good. I'll show you how much in a second. Then that moves right here into Missouri and Illinois, adding more snow Thursday night and Friday morning. That then pulls into this part of lower Michigan. Good model agreement. See it? All right. Friday. By Friday at noon, our next system is trying to take shape. Now the models are taking the upper level wave and just stretching it out like this. So a lot of overrunning precipitation down here to the south. And as we play this forward, going into Friday night into Saturday morning, I'll be watching at that time frame for the chance for some stronger storms coming into the southeast. This again, late Friday night and Saturday morning. The timing is going to change a lot, but that's what we'll be keeping an eye on. And then that system moves quickly into New England. Now you're looking at this going, wow, look at all that snow. We better take a look at what we're expecting out of this for this upcoming weekend. Because I'll tell you, the models are not set on it. I won't dare show you an operational run. But I will show you this, okay? As we play this out, we're looking at the probability of getting 3 inches of snow. That's from that system coming through here late this week, bringing the probabilities up relatively high to this area, better than 50 to 60% chance. Then as we play forward beyond that, it's that next system that comes into New England. And if I just let this go out there it is. That's a 10-day outlook. You can see that the heaviest snows are going to be confined to this corridor and then sneaking down the front range, or excuse me, the central Rockies. No subtropical jet, Rob in California. All right. So what about week 2? Let's start out on next Tuesday. As we play this forward, deeper trough moves into the southeast. We'll see the temperatures because of that. What I'm going to be interested in seeing is next Friday the 18th, then Saturday the 19th, and then Sunday the 20th. I'll go back and forth. See this little guy right here? That little shortwave sweeps through those 3 days. And I just want to make a point to say, watch out in here. These little subtle waves that come through can sometimes initiate a lot of severe weather. But one thing's for sure, the Northwest is going to be getting it, and you can see that right here. That's the biggest, most positive anomaly out of this going out to week 2. But I need you to watch what will be coming through this area the 18th, 19th, and 20th. All right. Okay, let's finish this up with some discussion on temperature. This was today's highs on Monday compared to average. So very warm in the mid-Atlantic, but the front swipes on in. So that's Tuesday's highs. You can now see the Arctic air advancing by Wednesday. This was well forecast by the models over the last 2 weeks. There's Thursday. This is the setup, okay, for that next system. Now going into Friday, Saturday, and Sunday, pushes east. Now, we were anticipating that this shot of cold air was going to be relatively temporary. And we start to see that. The day 5 through 10 forecast moves that colder air from the Canadian Prairie east and starts to push it out. And the 12Z model run from the GFS Ensemble has now gone more moderate toward, this gets us out there almost to the equinox. And it's also in the ECMWF as well. So we're going to watch this temperature pattern. It's going to be quite volatile as that Pacific jet begins to shift around. Very quickly at the very end, I would like to just give you a quick international update. South America, we have a whole separate video coming for that. But look at Europe. Just north of the Black Sea in Ukraine, drier overall, but wetter into southern Russia and through this area, and quite wet across the Black Sea. Temperatures in this area are going to go over cold in a big way. First time in a long time we've seen the forecast go over cold in that area. But if we come back to this map, I would like to show you more heavy rain is expected along the east coast of Queensland, New South Wales, and Victoria. And the other day in Brisbane, or last week, the end of February, there were some places over here, now get this, some places in about a 4-day time span, like around Brisbane, which is here, that saw almost 800 millimeters of rainfall. And I can't convert that in my head. I'm just going to do this real quick. So 800 millimeters to inches, that's 31 inches of rainfall. That's incredible. And they're getting more storms now. So major flooding in this area. We got to keep an eye on this. Okay, that's it. Thank you for your attention today. I look forward to giving another update on Thursday. And we'll talk to you then. Thanks.